So hello guys. So hello. So on day one of Project Star, I left something to tell. What I left was, I left something related to regression, and it was like, what it's like, I left something related to, I think I left something, but I don't know what I left. I left something that's related to, linear regression. Okay, so linear regression, I think positive regression. Okay, so we know that this is, if I place this over here, so if I place this, oh, wait a minute, let me show you negative regression, right? So the reason why this is called negative regression is because uh, why uh, this is called negative regression. And talking about positive regression is like uh, this is one of the example of H. Just a second. Damn. So in today, I mean today we in day two of Project Star, uh, we be talking about these topics. These are the topics that we will cover today. So let's begin. Damn. So firstly, we'll be going from linear regression. We'll be The second topic will be logistic regression. The third will be difference between linear regression and logistic regression. So let's talk about first. Firstly, let's begin with linear regression. So linear regression is like we have, as we have already know that what linear regression look like. Linear regression equation is a is a it represents a straight line. So when we talk about the linear regression, we talk about straight line. And the linear regression can be positive regression. It can be negative regression. So positive regression is like when with the increase in independent variable, you see a positive increase in you see the positive increase in a dependent variable. Then that's what we call uh, positive regression. And one of the example of this is what we have already discussed about. This is an example of linear positive regression, and this is the example of negative regression, as we have already discussed this previously. So let's talk about this is one of the equation of we know that linear regression, y equals mx plus c. B is an example of linear regression. So here y means dependent variable, x means independent variable, and m is the slope of line. So what does m really represent is, what does m and really represent? We know that m is a slope, okay, but basically that's not what it is. So what it is you know we you know m represents, like if I change 1 unit in x, if I change 1 unit in x, there will be m unit, m value change in y. So if I give a value of x as 1, and the slope is 1 point, like let's say the slope is 2, then with 1 unit change in x, there will be 2 unit change in y. So that's what we call m. and that's what is M. Okay, so M is the slope of the line and B is the intercept. So B is the intercept. So here we have one of the example. So if you want to find you know, if you want to find let's say, like, if you want to find uh, for example, you know, let me give you one example. The example is like, you know, if, you know, let me give, you know, this is something that I watched from YouTube, you know. This is not my original video that I'm making. I learn, I make, that's what I do. So let's say that I have, you know, I have a pizza shop which sells pizza. Okay, okay, so I have a pizza shop. Okay, let's keep it at Pizza Hub. Okay, so I have something called Pizza Hub, and which sells pizza. Okay, that's what I have. This is the business that I have, Pizza Hub. Nice name. So this is what I have, and this Pizza Hub sells pizza. Okay, so the thing is, like, you know, we know that pizza comes with different sides. Okay, and let's consider that the size of the you know, the pizza uh, with size 8 inch cost something called 100 rupees. Okay, the pizza that cost that is with size is 10 inch, you know, this cost 200 rupees, and the pizza that comes 12 inch cost, you know, 250 rupees. Then what would be the price of pizza with wood size is, you know, uh, 20 inch? What would be its cost? So to, in order to find this, you know, we can use something that is called this table. You can use this table, and you can generally, you know, find the pizza size. So in order to do that, we already have one equation. So that the equation is, you know, it's like the equation of y equals mx plus b. As we know that this is an equation of linear, you know, this is linear regression equation. Y equals mx plus c, mx plus b, where we know that this is independent variable. So dependent variable. So we need to find this independent variable. Okay, and in order to do that, we need to find m, and we already have, you know, x as 20 inch, and we also need to find the value of b. So the value of b is, you know, so what b really is like, b is something called, you know, equivalent to mean of x is dependent variable. So in order to find the size of pizza whose size is 20 inch, we can find the cost of 20 inch pizza. Okay, so if we use this equation, then we can definitely find the size of pizza whose inch is, you know, 20 inch, whose size is 20 inch. So, like, you know, you can use other equation too, so that you can find, you know, like, you can even use a different equation in order to find the, you know, all the problem. Like, in order to solve all the problem, you can use this kind of equation. So the next is logistic regression. So logistic regression is like supervised classification, and what we do is we use something called supervised classification, and it's generally binary 0 or 1. This is called logistic regression. Logistic 0 and 1. Why 0 and 1 is because you know the reason behind this is uh, let me show you one chart. Let me use this, let me use this, and let me use this too, and let me use something. Let me use this, and let me use something that is called this. Generic also, sorry. Then question looks like this. 0.5. So we need to like you will get a value in a scale of uh, you will get a value in a scale of 0 to 1. Okay, so if the value is greater than 0.5, if the value is greater than 0.5, then it belongs to 1. If the value is less than 0.5, then it belongs to 0. So we just need to find you know like whether the value of y is greater than 0.5 or like less than 0.5. So that's what we need to find. If it's greater than 0.5, it's going to be like 1. If it's less than 0.5, it's going to be 0. So in order to use this equation, like let me give you one example, like uh, this example, study hours and exam result. So let's say that there is one student who studies 2 hours. Okay, then he's going to get failed. Okay, he will be failed in the examination. If there is one student who studies like 3 hours, he will also be failed. There is one student that is who studies 4 hours, you will definitely be passed. So this is some kind of example of logistic regression where we can find this whether the student gets passed or failed. But we can't find like you know this is some kind of like example, like I'm just explaining you how this uh, logistic regression looks like, and how the data actually looks like, like how the data of logistic regression actually looks like. So that's what I'm going to say, like that's what I'm explaining. So let me tell you something that is related to like sigmoid function. A sigmoid function is like in order to find its logistic regression, in order to find whether the value like is 1 or 0, like what I need, what we actually use it, we use something called sigmoid function, and this is the function that we use to find whether the value is 0 or 1. So this is what logistic regression really is. So here what we do is we generally do something that is called classification, and we classify whether the value is true or false. Like we know that 0 is false and 1 is true. So that's how we generalize whether the whether something is you know true or something is false. That's what we generalize. Okay, that's what it goes logistic regression. And in order to find it, I've already said that we will be using something called a sigmoid function. and the value of sigmoid function comes between 1 and 0, and if it's getting in 0.5, it's going to be it belongs to 1. If it's less than 0.5, it belongs to something called 0. That's what it is. So let me tell you something that is related to difference between linear regression and logistic regression. So linear regression, let me tell you something about linear regression. So linear regression is something like supervised regression model, and this is a regression model is like Hazır la. So regression, like linear regression, is like something like supervised regression model is like supervised regression model. It's like you pass some value, you get some value. That's what it is. But logistic regression is it's classification model, supervised classification model. This is supervised regression model means that we all work with something called numerical values, but in case of logistic regression, we work in supervised classification model. That is, the value can be 0 and 1, whether it's true or whether it's going to be false. That's what we will be working on with. That is, generally we call this as binary digits. So generally, the dependent variable is dependent. It's generally dependent, like it's continuous, like 100, 200, 300, it's continuous. Okay. But in case of dependent variable is categorical, that is uh, categorized, whether it is good, whether it is bad, where it's zero. And generally we use, as I've already said, that is we're going to use something called binary data, that is 0 and 1, and that's what we were using. And we already know the equation of linear regression. The equation of linear regression is this. We generally use this equation to find like find the independent variable, and we know that this is classification, like supervised regression model. Means regression model means we will be working on with numbers. We already know that we are this all are number. We pass some value, we get some value, means value. That's why it's called regression. And in terms of logistic regression, it is classified whether it is 0 or whether it is 1. So that's the reason why it's called a supervised classification model. And we generally use an integer value to get an integer value. Means that we generally use an integer value. And in logistic regression, what we use is we predict a value by 0 and 1. So we generally use 0 and 1 to predict the value. So that's the end of the video, and I need to go for my dinner. Okay, so that's all for today, guys. So my parents are calling me, so thanks for watching, and this is the end of the video. So I'll be coming by today if I get a chance, like I'll definitely come to tomorrow, like not today, tomorrow I'll be there to deliver one more video related to data analysis, kind of like that. But thanks for watching, everyone whoever have joined the stream. Thank you a lot. Thanks a lot, and I have to end the video right now. So